Hello, this is Margaret Crevar. I work in the SAS R&D, and I help out with customers who have performance issues. And in doing so, we learn lots of information about how to run SAS on various hardware. One of the trends we're seeing right now with SAS users is their desire to move their SAS applications, whether it's 9.4 applications or new SAS VIA 3 applications, up to the public cloud. There are many reasons in doing that, but one of the things we've learned in helping customers move there so far is that you need to really understand what you're doing and what you're hoping to achieve in order for this movement of your SAS application to the public cloud to be successful. So that is the reason for my paper, Important Performance Considerations when Moving SAS to a Public Cloud. I'm going to start off with a disclaimer here. As you can imagine, things are happening on a monthly basis, sometimes even on a weekly basis with public clouds coming out with new instance types, new storage types, new whatever types, new enhancements, all kinds of information. So the information that's in my published paper is based upon what was available at the time the paper was published in March of 2020. And the presentation I'm talking to you about today is based upon when I'm actually recording this presentation. Next week, there might be some additional information to be said. And when we do learn additional information, we do post this in the SAS community for administrators. But we're happy to say that the public clouds are listening to the needs of SAS applications and are enhancing their instance types and storage to meet you, the user's needs. So let's get started. In order for you to be successful with your moving of your application from on-prem up into the public cloud, is you really need to have a very, very good understanding of what your existing SAS application is doing. If you have any SLAs, service level agreements that have to be met, all of that information needs to be known to help you decide on the instance type, the network connectivity, the storage types that you would choose when moving your SAS application up to the public cloud. You also need to determine what the success criteria is for you to move an existing SAS application up to the public cloud, or if you're going to be standing up a brand new application. We have a lot of existing SAS 9 users looking to start using VIA, SAS VIA, and they're doing that by starting it up in the public cloud to understand the needs. So just some kind of success criteria needs to be known, because that will help in the decisions of what instance types to use. Another thing to mention in order for you to be successful is you have to understand everything needs to be close to one another in the same general location. That includes your source data. That includes third-party tools, for instance, authentication tools, and your SAS client. If you have this information spread all over the continental United States or even across different continents themselves, then you will experience a lag in performance because you'll be using a WAN versus a LAN connection, and it just takes longer for the movement of data. So let's get into some general information about what's going on. Whether you're a SAS 9 user with your compute tier, and if you're running SAS Grid, there will be multiple compute tiers that are having to do heavy analytics. Your requirement of a shared file system for storage for these compute tier nodes for SAS Grid, and your mid-tier and metadata servers, or you are a VIA user with the CAS controller and worker nodes, which would be, in a SAS 9 perspective, similar to the compute tier, microservices and Postgres, and then also your SAS programming runtime node. You need to understand what the activity is going to be, how much work is going to be on them, what I/O throughput you're going to need when you go to move to the cloud. And then we have to look at the information that's available to you from the actual cloud providers. to see what you can meet with the different instance types. One thing for sure that you're going to want to do is in the compute tier for the SAS 9 and the CAS controller workers for the SAS VIA, you're going to want those all to be the same family processor set for Intel processors. They all need to be Skylake. They all need to be Broadwell. In Amazon AWS, it's very easy to do that because each of their instance families are only dedicated to a single Intel chipset. However, with Azure from Microsoft and Google, you could have a family series that could be either Broadwell or Skylake. So you'll have to work with that cloud provider to ensure that all of those components are the same processor speed. It just works best because in doing certain things on a Skylake can run twice as fast than on a Broadwell. So you would not, in a SAS VIA infrastructure, want to have some of the workers finishing up in half the time of the other workers. It's just not a good thing to do. So those are some things to think about when you're doing that. Also, when you go to, one thing that I will mention is in my paper that is published on the SAS Global Forum website, I go into a lot of detail about the different instance types for the Amazon AWS, for MS Azure, for Google, and for Oracle Cloud offerings. And I'll talk about the pros and cons for each of the types of the bullets you see up here for SAS 9 and SAS VIA. I will go into which instance type is good for SAS and which is not, and give you the reasons why they're good. But some of the things I want to mention to you right now is the fact that when you go to stand up your instances and your storage, one of the things you need to make sure that is happening is that you're in a region. Everybody's going to want to have all these machines in a region, but within a region, for most of the major public cloud providers, they have area zones, availability zones, area zones, AZs. You're going to want to be within that because the region could be east for, say, Amazon, and then they have 4 availability zones within Amazon. So you're going to want to have the area zone to be the same. That might be Virginia, for instance. So you have East and Virginia. But even in Virginia, they're across a couple of cities. So you're going to also want them to be in the same placement group, placement proximity group, however the verbiage is for the public cloud vendor that you're working on. So you're going to want to make sure that you're all there together. That means all of your components are close to one another. They're on a LAN. They're not having to go through firewalls. They're not having to go through multiple networks, routers, and things like that. You'll be able to get the best performance possible. So that's one of the things that you need to do. When you go and you work with Amazon, for instance, for standing up the same things, they also have what they refer to as a clustered placement group, which means all of the components that you're working on will be on a low network latency, high network throughput. So communication is going to be very, very fast between those. From an Azure perspective, you're going to want to make sure when you set up the network the network connectivity is in the same Azure placement proximity group. Same kind of thing as with Amazon. You just need to make sure that things are as closely as possible when you're setting all of this information up. So there's a lot more in my paper that goes into more details, but for sake of time, I'm going to go ahead and move on to some other topics here that you need to pay attention to. Storage. Storage is one of the biggest things that you have to pay attention to, and you're probably going to end up spending a lot more money than what you had wanted to with storage, because in order to get the recommended I/O throughput that SAS has for both SAS 9.4 and SAS VIA, you're going to have to spin up a lot of disk. You're going to have to spin up a lot of capacity to be able to meet the I/O throughput. Again, my paper goes into a lot of detail about how to go about doing that, But some key things that I want to mention to you is if you are looking at Amazon, what you have to pay attention to when you're choosing your instance type is the network connectivity. So in some instance types for Amazon, you're going to see it says up to X gigabits of I/O throughput. That does not mean you can get 100% of that. You might be able to if nothing else is sharing the hardware, but for the most part, you're not going to get 100% of the 10 gigabit. So that's going to be a problem there. So that's why we tell you to go to the instance type in Amazon that has a dedicated gigabit NIC card in it. That way you are guaranteed to always have that I/O throughput. For SAS, on a processor that has 16 physical cores, you're going to want to have that gigabit be around 25 gigabits NIC card in there to be able to achieve the 100 megabyte per second per physical core. And that reminds me, I forgot to mention this already. Be very careful when you are looking at the information on the public clouds. They refer to vCPUs. You need to make sure that you understand whether that vCPU are physical CPUs or does it mean hyperthread is turned on. Most of the time it is hyperthread is turned on. So from a SAS perspective, you take that number, divide by 2, because we don't run on the hyperthread. We only run on the physical cores on that Intel system. And then that'll be the number of cores that you will be licensed for from a SAS perspective. And that's where majority of the SAS work will happen. It's on the physical core. So, for instance, there in Amazon, there's an i3 8 extra large. It has 16 cores in it, but it has a single 10 gigabit dedicated network card. You're not going to get 100 megabytes per second per physical core on that one. You're only going to get about 48. But Amazon has recently released the i3EN that now has a 25 gigabit NIC card in it, and you're going to get, that's double, so it's 2.5 times what you had before, and you will be able to make that 100 megabytes per second I/O throughput. If you're looking at going to MS Azure, Microsoft Azure, you need to go into their little on their website where they talk about the instance types and scroll all the way over to the right before you get the column that talks about network availability and network speed. There's a column there that says maximum I/O throughput. Microsoft has gone in there and when they set up the virtual machines in the VM software, the virtualization software that they use, they had put a hard cap on there that says the maximum I/O throughput you can achieve. So, yes, these machines have enough network capacity to give me 100 megabytes per second per physical core. But for instance, with the E32SV3 there, it has 16 physical cores in it as well, but they have capped it at 768 megabytes per second maximum, and that equates to only 48 megabytes per second I/O throughput. So that's something you need to look into, and if you really do need the 100 megabytes per second per physical core, then you're going to have to look at doing something else within Azure to be able to achieve that. So that talks about getting outside of the machine, outside of your instance, to physical storage that will persist upon a reboot. We also need to talk about the temporary storage that's in there. In Amazon land, you have their new instances have NVMEs inside of them, and that makes for very fast storage for you to be able to get at your for the temporary space. However, in Azure land, they only have a single, maybe a very small SSD drive, which is not as fast. It doesn't have the same disk capacity that Amazon has. But anyway, you just need to look into that. So because there's not enough space on the internal ephemeral drives, you're going to have your temporary data external to the instance type. So it's going to go through that same pipe that our permanent storage is going through that could not meet the 100 megabytes per second. Now you have two file systems needing to go through the same pipe, so it's going to mean a lot less speed. Again, I can answer more of these questions one-off with you. I'm sorry for having to go through them so quickly here, but meeting the time constraints of the presentation, I need to go over a couple more things, and then I'll be available to answer some questions. There also is going to be a lot of detail in the actual paper itself for you to be able to understand. I mentioned if you were using SAS Grid, a shared file system is a requirement. So what do you have available to you up in the public cloud? You have DDN's Lustre shared file system. It's available everywhere through the marketplaces associated with the public cloud. IBM Spectrum Scale, formerly known as GPSS, is available through the marketplace and Amazon. Amazon has a special usage of DDN's Lustre. They call it Amazon FSX for Lustre. Again, it's only available in Amazon. It's very fast, and it's very price performance. So it's a really good that. We've got quite a few large telecommunication customers using it, and they're very happy. Amazon also has their Elastic file system, EFS storage, available to you. You have to be careful with that because it does have a maximum I/O throughput for each file system. So you just need to go in, and in my paper I mentioned what that is. I also mentioned a couple of other caveats around this shared file system for you to be able to understand. Azure has their NetApp file system available, ANF. It is based upon, it runs on a NetApp per the title, and it uses NFS. So that is another shared file system. There are several limitations for using NFS in that there's not designed for doing heavy writes to that file system. So you have to be careful with it. We do have some customers that are successfully using NFS as their shared file system, but they're more what I'll consider smaller customers than what the typical customer is. So if you've got large volumes of data, if you have large amounts of writes that have to happen to the shared file system, I would not recommend using NFS. Some other topics to talk about, I alluded to this at the very beginning. Make sure all of your components that are part of what's going to be your SAS infrastructure in the public cloud are close to one another. I've helped multiple customers that have moved their SAS application up to the cloud, and they're unhappy with performance of SAS in the cloud compared to SAS on-prem. When we start peeling away the layers of the onion to be able to figure out what's going on, we realize either their authentication tool is still on-prem, but everything else is in the cloud. SAS is in the cloud, but their source data is on-prem, or their source data is in a different region within the cloud. All kinds of things like that do it. So you have to be very conscious of that, because when you start going through a WAN to be able to get data into where your SAS is running, your megabytes per second goes down into the 25 or less megabytes per second. So that just means it's going to take a long time to move your data over. And if you're moving your data over a lot, then that's going to be a problem. High availability is a discussion that you need to have with your technical architect for SAS when it comes to doing that up in the cloud. You may have to rethink what's actually needed when you get up there. The clouds have a 99.5% uptime. So they're going to be able to spin up a new instance for you very quickly. And if you set up your instance correctly and that you have it backed up to an AMI or some other kind of device, then you'll be able to spin the new hardware up, attach the AMI, and be up and going in minutes. So, those are some new things to think about of that. So just some other things that need to be thought about, different ways of doing high availability in the cloud because of their offerings for keeping their hardware up and running at all times. So in conclusion, what I'd like to talk about, to remind you of, is you need to understand the complete workload and what's expected of the workload when you move it up into the cloud, so that then you can decide and you can create things that are the infrastructure is correct to be able to meet the workload. You need to understand the limitations of the I/O throughput when you get up there, especially to external storage, and see how that maps into your expected SLAs and if you'll even be able to achieve it. Within the public cloud, they have the ability for taking one of these 16 physical core instances and cut the number of physical cores in half. It's called constrained within the Azure. They have a policy to do that. Now, from a SAS perspective, you would license only on the constrained cores that you're using, but from an Amazon, or actually that was Microsoft, but from an Azure perspective, you would still license for all 16 cores because that's what the machine is. So it's going to cost you a little bit more to do it, but you're able to set up something that can meet your SLA from an I/O throughput perspective. You need to understand about the fact that any time you access anything from outside your LAN that you're running on inside the public cloud, it's going to take a long time to get at it. Another one is instances, storage types are always changing up in the public cloud. And like what I mentioned before with the high availability, you just make a copy of what you're running, you spin down your instance, you spin up the new instance, like for example for the Amazon where they went from an i3 to an i3EN, and you attach your ghost of the previous one, and all of a sudden now you're able to take advantage of the bigger NIC cards, the extra NVMEs inside that. It's very, very easy, very, very simple to do. So one thing I want to mention is this paper that is on the Global Forum website it gets updated once a year in time for Global Forum. But there's also a website that we have on support.sas.com that we are putting additional papers on, especially ones that are specifically just for what you need to do to make running SAS in MS Azure successful. And that website is support.sas.com/KB/62/239.html. So that is something to mention there that you'll be able to look at and get additional information. So I want to thank you for listening, and my contact information is here if you have any questions after reviewing the paper that's on the SAS Global Forum website.